Okay, so for this video we're going to be looking at elastic and inelastic collisions. In elastic collisions, momentum and kinetic energy are conserved. In inelastic collisions, the momentum is conserved, but the kinetic energy isn't. So first thing I'm going to do is take this slider and move it all the way over to make this a perfectly elastic collision. This is box 1, all the data is on the left-hand side. Here is box 2, all the data is on the right side. So first thing I want to do is change this to have a velocity of 5. I'm going to give this a velocity of 0, and I want it to be of equal mass. I'm going to turn off this clicker right here, which is the center of mass, and now let's click run. Red box went in towards the right at 5 meters per second. After the interaction, it stopped. It had a total of 62.5 joules of kinetic energy and 25 kilogram meters per second of momentum. After the interaction, it had no kinetic energy and no momentum because it was at rest. The blue box started off at 0 meters per second, which means it had no kinetic energy and no momentum. After the interaction, it is now moving towards the right at 5 meters per second. It now has the 25 kilogram meters per second of momentum and the 62.5 joules of kinetic energy. So essentially, the kinetic energy went from the red box to the blue box, and the momentum went from the red box to the blue box. And we can see by looking here at the velocities that the red and the blue have essentially switched velocities. Same thing with the momentums. Let's have the blue box moving towards the red box. So I'm going to put in -5. So the red one's moving towards the right at 5 meters per second. The blue one is moving towards the left at 5 meters per second. Red box is moving to the right at 5 meters per second. After the interaction, it's moving to the left at 5 meters per second. Blue box is moving to the left at 5 meters per second. After the interaction, it's moving towards the right at 5 meters per second. Kinetic energy was 62.5 before the interaction, and it's 62.5 after the interaction. It had 25 kilogram meters per second of momentum before the interaction, which is essentially changed over to the blue box, and the blue box had -25 kilogram meters per second of momentum before the interaction, which is transferred to the red box. So momentum and kinetic energy have been conserved. Let's make this a perfectly inelastic collision. I'm going to have the blue box with an initial velocity of 0. In a perfectly inelastic collision, the boxes will stick together. So here's what we have. The red box is moving towards the right at 5 meters per second. After the interaction, it's moving with half that velocity. The blue box was originally at 0. Now it's moving at 2.5 meters per second. The total energy of the system before the interaction was 62.5 joules. The kinetic energy of the red box is only 15.6, and the same with the blue, which if we add them up does not total 62.5, and this little gray area down here is actually showing you that kinetic energy has been converted into other forms. So we have, in quotations, lost 31.25 joules, which more than likely would be due to heat of the boxes or the items when they stick together. So the total momentum of the system was 25 kilogram meters per second before the interaction. After the two boxes came together, the red box had a total of 12.5 kilogram meters per second. The blue box had a total of 12.5 kilogram meters per second, which when we add them together gives us the original 25, which shows us that momentum is conserved. So elastic collisions conserve momentum and kinetic energy. Inelastic collisions only conserve momentum.